All right, welcome. Today we're going to do a lesson on molarity, and our objectives are defining concentration, define molarity, and do calculations. That'll be the bulk of what we do, and then how you make a solution of a given molarity. Molarity is a way of measuring concentration. So concentration, this is really the ratio of the amount of the solute to the amount of the solution. The solute is, if you're putting sugar in water, sugar is the solute, and then water is the solvent, but together they make up the solution. So the sugar and the water together make the solution. So, as the amount of the solute goes up, the concentration will go up. And there are various ways of measuring concentrations. You might be familiar with, alcohol. The rubbing alcohol says 70% on the bottle, 70% isopropyl alcohol. And so what does that mean? It means that you've got 70 milliliters of the alcohol for every 100 milliliters of the solution, and that other 30% or 30 milliliters will be water. So that's a way of measuring concentration that you're probably familiar with. Another way is parts per million. And the EPA will have just allowable limits of various metals in water. And these are some of the more dangerous metals in water. And these allowable limits are measured in parts per million. That's what ppm stands for, is parts per million. And if it's a really low level, it will be in parts per billion. And so for every million parts, they're using milligrams and liters. Usually you don't mix up mass and volume, but when you have very small amounts, it doesn't matter so much. But if you could think of it as if you have 1 million milliliters of water, there's going to be 5 of them that'll, or maybe grams would be better. If you had 1 million grams of water, then there's going to be 5 grams that are the allowable limit of arsenic. So those are some ways of measuring concentration. When in chemistry, we use molarity, and molarity is defined as moles of solute per liter of solution. And you should remember that when you're talking about the solution here, that's got the solute and the solvent. So here it's just the solute, and it's in moles, not grams, but moles. And then you're dividing it by the solution, and the solution itself contains the solute and the solvent. And you should make sure you're aware of that, so maybe write that in. So the solution has got the solute plus the solvent. All right, so here's an example of preparing a 1 liter solution of what we call this a 1 molar solution of copper 2 sulfate pentahydrate. That's what that is. We've used that in a couple labs. It's the blue crystals that we drove the water off and they turned gray. So I've got a molar mass already calculated for you. Take 1 copper plus 4 sulfurs plus 4 oxygens plus water weighs 18. You'd multiply it by 5 and then add it in to the copper sulfate, and you end up with 249.7 grams per mole. So here's the kind of the procedure, and I've got pulled up a little bit of a video that can show you what to do there. So you're weighing out how many grams you need to get you 1 mole, and when we do the calculations, we'll talk more about how that works. Anyway, so that's the amount of grams that are going to give you, let's say, 1 mole of that. He's not using copper sulfate, he's using something else, but we can just pretend. And so you add it to the volumetric flask. That's the flask that he had there. It's got the long neck and the round bottom to it. And now we're going to rejoin this. He's going to add some water to it. Notice how he's not filling it up all the way. He's just going to fill it up about halfway or so. That's to give you some space to swirl this and dissolve the crystals. So you want all those crystals dissolved before you add the rest of the water. Because remember, we're going to have he's a liter of solution. That's what molarity is. And so you want the solute all the way dissolved before you finish up, and you're going to add it to that line right there. Once you get close to that line on the neck, you just start adding dropwise with a pipette or something, and you want to get right to there. And you want the bottom of the meniscus to sit right on that line, and that's what he's got right there. Then you would put a cap on that. See, the mix the solution. So you put a cap on it and then invert it a few times to completely homogenize it. All right, so that's how you do this. That's what this says right here. And so if you had put, we would have put 249.7 grams in a 1 liter flask, and put then added it halfway with water, dissolved all the copper sulfate, and then filled it up to the line, so the meniscus is resting on the line of the flask. All right, so that's how you make a solution of a given molarity. And we're going to look at some molarity calculations. Notice I'm going to probably just do 1 or 2 of these and then stop and finish them up, the rest on another video. But we're finding molarity given moles or grams of solute and the volume of solution. So here's one we're going to plug in for moles of solute, liter of solution, so that we can get molarity. And we'll look at a couple of those examples. Notice that there are other types. I've got type 1 here, and then here's type 2 is finding grams of the solute, and 3 is finding volume of the solution. So really there are 3 parts here. There's the molarity, there's the solute part, and there's the solution part, and those are the 3 types. The first one we're finding molarity, second we're finding grams of the solute, and third one we'll find usually milliliters of solution. All right, let's look at the first one. This first one says, what's the molarity of a 400 milliliter solution containing 0.25 mole of Ki? So remember, our molarity is going to be moles of the solute, which in this case is potassium iodide, and then we want per every 1 liter of solution. That's what we're after, per every liter of solution. So let's see what we've got up here. We've got, for the liter of solution, we've got 400 milliliters. And for the moles of solute, we've already got that in moles. We've got 0.250 moles of potassium iodide. So this one, we've got the unit we want, moles and moles. So nothing needs to happen here. But on this one, we need to get these milliliters to be liters. So we'll put liters of solution down here to cancel. Milliliters down here to cancel, and liters up here. And for every 1,000 milliliters, there's 1 liter. And that's what this is right here. That's a capital L. So you're dividing by 1,000, which means you're moving the decimal back 3. 123.400 liters of solution. All right, so now we can bring these 2 values back into our formula. Molarity is the moles of solute, 0.25 moles for every 0.400 liters of solution. And then if you do the math, you're dividing 0.25 divided by 0.4. I'm getting 0.63. We have 2 sig figs and 3. And so that's we need 2 sig figs, and we got them. And then your units aren't canceling. You have moles of solute per liter of solution, and that's what molarity is. So the unit is just capital M, and it's implied when you see capital M that there's an embedded unit, moles of solute per liter of solution. So that says you have, if you had 0.4 liters of solution, you had 0.25 moles. But if you have 1 liter of solution, because that's what molarity is, 1 liter, if you have 1 liter of solution, then you'll have 0.63 moles. All right, so that's one example. Here's another one of the same idea. We're looking for molarity. We have 125 grams of sodium chloride, and then we're adding it up to the final volume is 2 liters. So that would be a 2 liter flask that's being filled. So once again, we want moles of solute, which in this case is sodium chloride, and that's going to be for every 1 liter of solution. All right, so let's see what we got going on here. we have 125 grams of the sodium chloride. So that needs to be moles, so we need to do a conversion there. And let's see what we know about the solution, 2.00 liters. Okay, and we want liters of solution. We have liters of solution. So we don't need to convert that, but we need to convert this here. So we'll put grams of sodium chloride down below, and then we're converting that to moles. And so we're going to look up sodium chloride's molar mass. We need how many grams of sodium chloride per mole. It's a NaCl. So we're looking up sodium is 22.99 right there, and chlorine is 35.45. So we have one of each. We'll add them together, and we'll get 58.44 grams per mole. So that's a molar mass. So you're dividing 125 divided by 58.44, and I get 2.14. Grams canceled out like we wanted, and we have moles of sodium chloride, which is what we need for our numerator. The denominator was fine. So once again, molarity is our moles of sodium chloride. Well, let's just plug in right here. We've got 2.14 moles and 2.00 liters of solution. So we've got 3 sig figs top and bottom. We'll do the math and round. I'm getting 1.07. What's the unit? Capital M for molarity, meaning you've got 1.07 moles of sodium chloride for every 1 liter of solution. Okay. And I'm going to stop the video there, and so we can, so I can, there I am. Okay, so I'm going to stop the recording, and can carry on the rest of the calculations on the next one.